Hello and welcome to the lecture 25th of the course on financial econometrics. So today is the last lecture for the fifth week. So in the fifth week basically we have discussed about the concept of stationarity, its implications and the concept of unit root and unit root tests. So we have discussed different unit root tests to examine a series whether it's a stationary or non-stationary. Today we will be implementing those concepts using the software R. As we have discussed in the previous lectures that now we will be using the script file and the project folder. So already you know how to create a project folder and how to create a script file. Here you can see in the screen that I have created a project folder, and right now I have opened that project folder here. The name of the project folder is FER. So basically I have made this project folder for all the cases which we will be using for hands-on practice for this particular course. So today we will be using for the unit root tests. So here the script file we have created. So let us open this script file. So here you can observe that we have opened the script file. The moment you open this script file, here you can see a warning message, and with that message you can see here these are the different packages which are not installed in this particular system. So do you want to install? So obviously we will be using these different packages, so we'll install. So if you click on the here install, so you can see automatically here it's the job is being done, and here you can see that it is installing those different packages. So in this particular session we will be using 4 different packages, that is read XL, which already we have discussed. This is basically for importing the Excel file. Then there is another package Psyche. Basically this will be using to find out the basic statistics. URCA is specific to time series analysis, which we will be using for this unit root test. Then there is the alternate package is T series, that is for also for unit root. However, there are other alternative packages are there. Primarily we will be using URCA, which is the most comprehensive packages we have for the unit root test. So once we have started this, then the first task we have to execute the library function to basically attach these packages for this particular session here. So let us run different this. So you can see now here all those different packages has been attached to this. However, in the console you can see we have different text in form of red text. So this is basically a warning, but it doesn't have any implication in executing those programs. So once we have attached those library, the next thing we will import the data. As we have discussed earlier that if we are using the project folder and the data are in the within the project folder, then there is no need to give the path. So here therefore we are not giving any path for that. So here you can see the BSE auto. So that is the assignment operator. Then the main function is this read underscore XLSX. So that is basically to import the Excel data in the Excel format. So here this is the basically name of the data folder, so that you can see here we have listed those data here. So now we are importing this particular data, and the data name which I'm keeping here is the BAC auto. So once we execute this either using the control enter, so you can see that here we have created that particular data. Now if you click on that data, we will be able to view here. So if you see this particular data here, so what we have here, this is the month, so date, then the open, high, low and close. This is basically the data on the BSE 100 indices, and this is the monthly data. So here we can have 1st January 2000, 2nd Feb 2000, so on. So this is the monthly data. So NA basically, so that means those observations are not available. So here we can say from 2004 onwards we have open, high, low and close, all those observations are there. Similarly, we will be importing the second data. So that is the BAC Sensex here. So you can see these are the data where we have high close this data. Then the second is about the Tata Motors. So we will execute this data, and here we can see that this particular data has been added here. So if we click here, either we can use the command of view, then inside that parenthesis we have to write the name of the data file, for example Tata Motors, and if you execute it, we can see these are the basically we have data. So there are the many variables are there in this particular data file. So open price, high price, low price, close price, numbers of shares, numbers of trades, total turnover, delivered quantity, all those informations are here. So we have imported 3 different series. However, we will be implementing the unit root test on any one of the series. The process remains the same. So this other 2 series is basically for you to exercise. Now once we have imported, we have seen that in individual data there are the different columns for the different informations we have. So now we are creating the working data, basically collecting all those data from those 3 different files which we will be using, or which are the basically concern for us. So that I am creating here W data, that is basically working data here. So for that I am converting that as a data frame, and here I am importing this BAC month. So BAC auto is the data frame name. Here you can see this. Then month is the basically the month column we are attaching here. Here dollar is the assessor symbol, which already we have discussed in earlier previous lectures. Then comma, the next BAC auto, and from that we are taking close, that is the close price. The similarly the BAC Sensex and the Tata Motors we are taking all those. Then once we have taken, if you execute this, so you can see here we have created a working data. If you click now here, so we can see what are the basic things. So BAC auto month, so that is the BAC auto data we have taken this month column. Second we have BST auto close. Third we have BAC Sensex close, and this is the Tata Motors close price we have taken. However, we can see the other different names of the columns. So let us give a concise name of those columns. So for that what we are doing here, so we are writing column names W data. So column names is the function here, and the W data is basically the data file name. So we are changing the column names of this data file working data. For that what we are doing, we are using this concatenate function C. Then here I am putting the first column name should be date, second column name should be BAC auto, third column name should be BAC Sensex, and fourth column name should be Tata Motors. If we execute this, so here we can see now this data here. So you can see in place of month, now it is date, here BAC auto, BAC Sensex, Tata Motors. So we have changed the column name using the function of column names. Now let us, first thing we will do, let us see what are the structure of that particular data we have. So to know that, we have used the function str and then the data file name. So if we run that, we can see here in the console, you can locate it here. So these are the data structure. So first it is a data frame. So the data has been stored in the data frame. Then the first column is date, and it is showing it is a character. So it is not a number. Second, BAC auto, you can see this is a number. Third, BAC Sense, it is also number. Tata Motors, it is also in the number format. These are the few observations here it is showing. So basically you can see there are the 298 observations of 4 variables. So 3 variables are this, and date is the one of the variable they have considered. Now let us say if there is any missing value in the data, because the missing value is very important in the financial analysis. There will be certain models where we will not be able to implement if there is the missing value in the data. So we are checking here is there is the missing value. For that we have is.na. So you can explore what are the other functions we have related to this into the help file here. So if you write here is.na, so you can here see this. If you import here, so here you can say not available and missing value. So generate function is, so this is the basically you can use how we have. So this is the whole detail we have how we'll get. So here basically we'll get the output as a in binary. whether true or false. If there is the missing number, then it will show true. If it is there is no missing number, it will show a false number. So here the other things are is there. So false, true. Here we have. So these are the things which we are concerned with this here. Another thing is there is the related case here. For example, NA omit. NA omit is very important function. So NA omit basically, if there is the missing number, they will drop that particular rows for every column. So that's the basically here you can say NA omit object you have to give. So there are the options arguments here how you will drop that. So NA omit is also very important function here in case if there is the missing value, then what we will do, we will use the function NA omit and we will drop that particular observation rows. So let us run this. Here we can see there is false, false, false. That means there is no missing number in that. Then here, whether we have imported data correctly or not, one way to check that, if you check the first few observations on the top and the last few observations at the bottom. So for that we have NA head and tail. So basically by default they will show the first 6 observations and the last 6 observations. However, that can be manipulated. So head and tail. So here you can see it is showing the first few observations. So now you can match with your data whether it is true or not. Similarly, in the last observations we can see here 298. So we can match this whether the data is correctly imported or not. However, we can change that. Let us say instead of 6, I wanted to see the first 10 observations. So you can write 10 and here we can, if we run here, so you can see here they are showing now here the first 10 observations. So that can be manipulated. By default, it shows the first 6 observations and the last 6 observations. Then first thing we'll do the summary of that data. So if you want a summary, so it will basically show you the minimum, the first quartile, median, mean, third quartile, maximum. So these things already we have discussed in the detail. Here our objective basically unit root. So quickly we'll move to the unit root. So another thing which we have discussed earlier, if you want to further in more descriptive way, then we can use describe from the psych package. So here we have this. So in this case we will have number of observations, mean, standard deviation, median, trimmed, mean adjusted, median adjusted, absolute value, minimum, maximum, range, skewness, kurtosis, standard error, those things we can observe. Now, once we import the data is into the data frame. However, to use the time series models, we have to convert that into the time series framework. So for that, what we are doing here, we are converting that working data which has been stored as the data frame into the time series data. So here the TS W date 2 into 4. Now the first observations in our data here, working data, is the date which is in character format. So we are not taking that. So basically we are using here TSW. So call from the second column to the fourth column. Then starting date. So we are writing start date from 2000 first month. Then frequency is 12. Now if we implement this, so here you can see we have added a TW. Then here you can see the option is time series, and if we click here, then we can observe here without date. Here we have BAC Auto, BAC Sensex, Tata Motors. However, the R has automatically attached the date from January 2000 onwards. So this is now, let us say if you wanted to examine, though in the data there is no date column, however they have stored that in their information system. So here if you see, I wanted to see what is the start date. So start and the working date, that object name of that. So we write here. So you can see the starting date is 2000 in the console here. We can observe that. Now what is the, so you can observe here the starting date is first, means month January, and the year is 2000. Similarly, we can observe the end date. So here we have end date, that is 10th month and 2024. Then what are the frequency we have of this here? So we can use the frequency. Then here we can see 12. So because it is a monthly data, it is showing the frequency is 12. Now, once we are certain about the data informations, we have the basic minimum information about the data. Now, before implementing the unit root test, it is better to have the visualization. As we have discussed in the previous lectures, visualization is the one of the first step in the time series modeling. So for that, let us say we'll be using plot, which is the base R command to plot the data. So here we are using the plot. So this TW is the basically information of that particular data set. Main is the basically what should be the title of the graph, and xlab what should be the label of the x-axis, and similarly what is the label of the y-axis, and color is the red for those graphs, and LW is the what is the line width. So we have given two. Type is basically how it should be drawn, how it should be represented, that is L here. So we are plotting this. So here we can see the observations. So plot lines are the line type of graph. So here we have the, so once if you are showing jumble here, so you can zoom it here. So a window will pop up. So here we can see that these are the plot of this. Now similarly we can use the time series plot from the time series data TS plot, where basically we are plotting entire data into the same graph. Here we have 3 layers of the graph. So rather than, if suppose you wanted to in the same x-axis and y-axis, so if you are implementing that, then here you can see we have the same data here. So here in this case we have the prices, and here we have indices. So we have kept this name. So those things here we have done. Column 1 is to 3, xlab is year, ylab is prices, main name is the BAC indices, line width is 2, line type is 1. So by changing the line type, it will be change the appearance of graph. For example, if I am writing 2 here, then if we run this particular command, so he can say instead of the continuous line, it is a dashed line. Now here we don't know which red is representing which series and the black is representing which series and all. So that for that we will be adding the legend here. So once we add the legend, so it shows that black is the BAC Auto, red one is the BAC Sensex, and green one is Tata Motors. Suppose we wanted to draw only individual series. For example, here I am drawing the first plot. So we can plot the first one. So here you can see the TWD here. So this is the first plot. Now what is the first plot in the data? So the first plot we have the BAC Auto. So if you wanted to supply that information, and here we can write xlab is BSE Auto. So if now it will be the ylab. So here the ylab is equal to BAC Auto. If we run here, so you can see instead of the information of TW, the first column, here we have BAC Auto. So that's how we can plot the individual thing. Then here basically we are using that, we are taking the log of all the variables. Basically when we are taking log, it reduces the variability here. So let us say here we are taking the log of the data. So here you can say we have created another time series data with the name of LWD. So this is basically had reduced the variability of the data. Now once we have done this, so basic structures we have seen. So as we have discussed in the previous lectures, that if the series looks like this, then we might suspect there is the problem of non-stationarity. So before doing any further analysis, first task is to ascertain how many unit roots are there, whether we have to make the difference, whether you have to make the detrend in the data. Further, we will be using the unit root test to examine the existence of the unit root in the present data. So here unit root test at level means basically we are not differencing, we are doing the unit root test on the data which we have already here. So we have discussed in the theory the ADF test, Phillips-Perron and KPSS. These are the 3 tests which basically we will be discussing here. So this ADF test we have used from the package URCA. So that means to use the ADF test, here we will be using the URCA package. So here these are the different information we have given. So the general framework, the general functional form of ADF test is this, that is ur.df. Then you have to provide the data file name, then the type basically we have, if you remember, we have three different equational form in Dickey-Fuller test or in augmented Dickey-Fuller test, that is without constant and train, with constant but not train. At the last we have constant as well as trained in the regression equation. So similarly here none means without trained and constant. Drift means basically we are adding constant but not the trained. Trained means basically we are adding both. Lags here basically either you can specify your lag or we can use any information criteria to be choose to decide the lag. It is always better to use the information criteria to decide about the optimal lag length if you are using the ADF. So basically here we are using, so here the ur.df, basically we are calling the ADF function using this particular command. Then this is the basically information of the data. So here we are saying time series this data and the first column we are using. So basically we are experimenting on the BAC auto. So this is the case here. Then type, the first we are doing none. So that is we are not including either constant or train in the regression equation. Select lags. So basically we are using the AIC, that is Akaike information criteria, to choose the optimal lag length. So we have executed this particular code and you can see in console there is no result. Why there is no? Because we have stored that result into the ADF. Now here you can see all the lines are in the blue. There is no red text or messages. That means we have successfully executed the ADF test here. Now let us find out what is the result. So we will be using summary ADF. So if you are using summary ADF, so here we can see the result in this case here. So these are the results we have. So let us give us few seconds to observe the certain observations about these results. So first line basically, if you can see here, there are the basically three part of this result. So the first part basically says here in this case, what is called, that means what commands have been executed with what options. So you can see here, so all those informations are given here. Then the second part of the results is about the regression equation which we will be doing. So this part is the information about the regression equation which we have done here using this LM linear regression model using this. Now most of the time we are not concerned about these results. The concerned result is basically for us is this part. So here you can see the value of the test statistics, that is 3.4419. And here you can see the critical values for the test statistics. Here we have tau 1, that is at 1% level of significance it is minus 2.58, at 5% minus 1.95, at 10% minus 1.62. So as we have discussed that if the absolute value of the test statistics is more than the critical value, then we will reject the null hypothesis. So here you can see the test statistics is coming 3.449 and here basically we have 2.4858 at 1%, minus 1.95 at 5% and 1.62 at the 10%. So in this case what we can observe here, that this test statistics is more than this. So for us basically this is the third part of the result which is we are concerned with. So here we have discussed that in the theoretical class that the test statistics should be more negative than the critical value to reject the null. So here we say this is the positive value and these are the critical values are in the negative form, then we can say basically we are basically not rejecting the null. What was the null? Null was that the series contains unit root. So that obviously by looking at the graph of the BSc auto, here you can see, yes, this seems there is the non-instancity in the data. And here we are getting confirmed by the ADF test. Now, let us see the other formulation of the ADF. That is, here we are using the drift. So, if you are using this particular series formulation of the data, then you can see here again we got this. So, all the results are again here. So, however, primarily we are concerned with the last part of the result, that is this part of the result. So, here we can see value of test statistic is 2, they have given 2.3419, 5.9033. So, basically this tau 2 and tau 5 is here. This phi 1 is basically gives us combined significance test of the parameter of alpha plus gamma, because here our equation is now, see, in case of the second formulation of the ADF test, what basically we are doing here, we are regressing delta yt is equal to alpha plus gamma yt minus 1 plus we are adding here lags of delta yt minus I plus ut. Here I is from 1 to k. So this is for the ADF we are adding here. So k basically we are using AIC or the BIC information criteria to decide what is the optimal lag length we have. Now in earlier case we have delta yt is equal to gamma yt minus 1 plus this particular term plus ut. So in that case we examined whether gamma is equal to 0 or gamma is less than 1. So that we have discussed here. So this we tested the hypothesis. However, in here in this case, one we are testing whether gamma is equal to 0 or not. Another is we are jointly testing whether alpha is equal to gamma is equal to 0 or not. So in the second formulation we have the two case. However, for us as a unit root, we are concerned only with this, not this. However, in R, that is the provision is given to both. So that's why here you have tau 1, the second is the phi here. So phi 1 is basically shows the joint significant test of alpha plus gamma. However, we are not primarily concerned with that. We are concerned with that only with the tau 2. So we will be using this 2.349 and compare this with the available here critical values. Again, if we can, here we can see this is the positive, this is not more negative compared to the critical value. So we cannot reject the null hypothesis. That means again we will conclude the data is non-stationary. And now then the last formulation in the ADF test is the third, where we have both constant as well as trend. So if we execute this, so here we can see again we have this result. So again we are concerned with the only last part of the result here. So here you can observe now we have three statistics 0.352, 4.1373 and 3.059. However, we are basically primarily concerned with this, not these two others. The reason is that this basically are assuming the second case alpha plus gamma both are joint is equal to 0. The third where alpha gamma plus trend, that is the status beta, is all are 0 at once. However, whether the series is non-stationary or not stationary, that depends only the value of the gamma. So we are concerned only with the tau part. So again we are looking here, we can observe that these are the more negative compared to the test statistics. So again here we do not reject the null hypothesis, that means we do accept that data is non-stationary. So all the three formulations ADF shows that data is non-stationary. We are not able to reject of null hypothesis. Next we will be performing the Phillips-Perron test, which we have discussed. So in the Phillips-Perron, basically this is the general formula we have, this. So here again, X is the basically data frame, type, there are the three types, Z alpha and Z tau. So this is Z alpha and Z tau is basic primarily related to how they calculate the test statistics. Because we have discussed that in ADF and the Phillips-Perron, the difference is that to correct the presence of autocorrelation, in case of ADF, we add the lag terms. However, in case of Phillips-Perron, they do not add the lag term, rather than how the test statistics has been calculated, they make the correction there. So based on the how they implement the correction, we have the Z alpha and Z tau, those two statistics. Then here model, constant and train. So again here we have the option whether we wanted to include constant, whether we included to trend or not. So lags here, short and the long. There are the basically two default methods we have to calculate how much, what should be the lags. So that is basically based on the number of sample observations. So based on that, there is the short, basically it gives a very lesser percentage to the total number of observations, where in the long basically we calculate a larger percentage of the total number of observations. Otherwise, use lag here. Basically, instead of using this short and log, you can define your own lag structure in this particular case. However, often we go with either short or the long, depending on what is the how many number of observations we have. So if you have the large observations, then it is there is no harm to go with the long option. So let us say the first part here, the unit root. To call that Phillips-Perron, what we have u.r.pp. Then here the same variable, that is BAC auto we are using. Then type here we are using the Z alpha, model basically constant, lags we have short. So let us quickly execute this command here and let us see what is the result we are getting. So here you can see these results. Again we have the three parts. So basically we are concerned with the last part here. So here it is saying Z alpha is 4.3299 and the Z statistics is here, you can see Z tau mu is minus 0.1167. So basically again the same rule, if it is more negative then only we can reject the null hypothesis. However, it is not negative, so that means we are we are not able to reject the null, we are accepting the null. Accepting the null means again that means there is series is non-stationary. So similar result we are getting as we have got in the ADF test. Now let us execute the second formulation in Phillips-Perron here. So here I have used the trend. So we can see what are the results we have got. So again here you can see this. Now here again we have the Z tau mu and Z tau beta here. So basically once you add that trend, you will get this. So this is again basically joint significance we have. So primarily, but however we are concerned with this only. So here you can see 1.0247 and this is again minus 0.3259. So again this is not more negative compared to critical value. So we are accepting the null. That means there is a unit root. Let us see the another case here. So instead of Z alpha, we are using the Z tau here. The other thing the same as the constant short. So if you are getting here, so you can see here Z status we are getting Z tau mu and we are getting the critical value here. So again Z tau is 2.679. Then here you can see minus 3.4, minus 2. Here minus 2.579. So in all three cases, again we are not able to reject the null hypothesis. That means again we are concluding the series is non-stationary. So let us execute the third case here. So again here we are seeing the same thing, Z status is 0.245 and here the critical value are given here. So again we have the case that the series is non-stationary. Now As we have discussed in the theoretical class, both these tests are tests of non-stationarity because the null is non-stationary. In this specific cases, we are able to accept the null. That means the BAC auto series is non-stationary, and the graphical method here you can see also reflects that aspect. Yes, it should be a non-stationary series. However, in some cases it has problem, as we have discussed earlier, that in the especially case where the yt delta yt depends on, let us say yt depends on the 0.95 yt minus 1 plus ut. So since this value of this, the let's say assume phi is not equal to 1, it is basically less than 1, then it should be, this series should be treated as the stationary. However, we have discussed that in quite often, especially in the small sample, so the ADF or the Phillips Perron, they are not able to distinguish between the 0.95 and 1. Quite often they treat is 0.95 as the 1, and they will conclude that the series is non-stationary, which is not the true. So therefore we use the other test, which is basically test of stationarity. That is, one of the test of stationarity is the KPSS, where the null hypothesis is that the series is stationary. So let us say how we implement that. Let us see how we will be able to implement that in case of R. So here again we will be using the same package URCA. From that we will call the KPSS test by using the function ur.kpss, again the time data, and here you have the two type, mu and tau, and the lags is short. So if we run here, this will get the results here. So here we can say the KPS unit to test of tie is mu with the 5 lags. So test statistic is 4.123 and the critical values are 0. These things. Since the tabulated value is more than the critical value, that means we will reject the null hypothesis. Here the null hypothesis was series is stationary. So at any percent of level we are rejecting the null. That means we are accepting the alternate hypothesis which is stationary. So that means there is no conflict between the conclusion of the ADF, Phillips Perron and the KPSS test. All three tests says that the series is non-stationary. Then we can use the other alternative in the KPSS case here. So again you can see here the similar result we are getting. The test statistics is this and we have the critical values are this. Again this is more than the critical values, that means we reject the null hypothesis and we accept that the series is non-stationary. So all three tests here reflects that the series is non-stationary. So once the series is non-stationary, before using it for the further analysis, we have to make the stationary. So one of the method what we have used, the difference stationary. So here we will be using that. So first we take the difference of the data. So here we are taking the difference of the data using the function diff. So diff is basically stands for the difference and call the difference function here. Then here we have written TW data. Here it is both are blank before the comma and after comma. So that means for you should consider all the observations, all the columns. So we are getting the first difference. Now suppose we are needed the second difference, that for that again difference of the difference data if you take, that will be the second difference. So let us first examine at the first difference. So let us plot first. If you are plotting this particular, so let us first take the difference here. So we are taking the difference, so that data has been created here, this dw, dtw, so basically difference of the data. Now let us plot this here. So you can see here all three series has been plotted in one single graph, and by looking the graph we can guess the series should be stationary. So here we are adding the legend. So here we can see what are the basically we have here. So here we can see this is the basically series we have. And by looking this, we can guess there might be the stationarity. However, you can see that as series increases, there might be the change of volatility. So let us examine that. So the same unit root we are testing here, and that is basically in the first formulation. So now here you can observe this. So let us see the last part. So here we can see that test statistic is minus 9.942, which is more negative compared to the critical value. That means we reject the null. Here the null was, there is the unit root. So that means we are rejecting that. That means the different series is stationary. Similar result we are getting other two formulations. So here again here it is minus 10.293 and the critical values we have minus 3.44 and this. So again at the all three conventional level of significance, the series we are able to reject the null hypothesis. That means we are able to reject that the series is non-stationary. That means the series is stationary. A similar result we are getting even in the third formulations here also. So here also you can see 10.6246 and the critical value here we have. So again same conclusion we are getting. Now let us quickly turn to the Phillips-Perron here. So again the Phillips-Perron same code we are using, only in place of the label data now we are using the differencing data. So let us see here. So here we can observe again here what is the this critical now the test statistic is minus 273 and critical values will have. So let us see here. So again we can see here this is the basically we have. So let us see the summary. So here you can see the critical value, sorry, tabulated value is minus 14.7832 and the critical values are this. Then obviously we can see this value is more negative compared to this value. That means again we are should reject the null hypothesis and null is unit root. Now let us quickly see the what is happening in the KPSS. Now here we can observe in the KPS basically null is that series is stationary. So we should accept that. So now if you compare here at 1% what is the test statistic has 0.739 and here it is 0.59. That means we are accepting the null because the tabulated value or the calculated test statistic is less than the critical value. That means the series is stationary. Similarly, here we are using this. Again, we are getting this 1.43. So here we can see here that we can basically it's at the very margin. So this is not a unique phenomena. Quite often time we may get that. In few examples we can get that there is a conflicting result with the KPSS test and the ADF and Phillips-Perron test, which is the basically we have discussed earlier in this. However, overall by looking at those two statistics and the KPSS test statistics, we can conclude that the series at the level that is the stock prices are non-stationary. However, when we differentiate, that is basically when we turn it into the return, then it becomes a stationary. In today's class we discussed, we have seen that how we will be able to implement those unit root tests in R and how we can interpret those results and can make the decision about whether the series is stationary or non-stationary. So in the next class, then we will be discussing the different models into the R. Thank you so much.